As we all know, the world is heavily dependent upon wireless communication, and that dependence is growing, especially with 5G. If an organization is not monitoring their wireless activities, then they really do not know whether there is authorized or unauthorized communications in their airwaves. Their wireless communications could be being compromised intentionally or unintentionally, and they would not even know it. We have a working prototype that addresses this need and will enhance wireless security. Next slide, please. The technical challenge for wireless spectrum monitoring is that there are a variety of tools that are unable to capture all the wireless signals, as well as scale with the state-of-the-art technology. Also, the breadth of signals is sometimes misidentified or fails to be detected. The technical requirements we are addressing here is to create one tool to capture both expected and unexpected wireless signals. We want to be able to scale small and large, indoors and outdoors, as well as detect and classify all types of signals. Another requirement is to provide a single tool that is simple for the layman user to use, so they do not have to have a lot of background knowledge and training to be productive. For example, a spectrum analyzer shown in the black and green diagram on the left is a common piece of equipment when working with wireless. But this device can only show a very limited portion of the spectrum with results that are difficult for the layman to interpret. This is just an example of one tool that could be used, but requires specialized knowledge to operate and has limited capability. Next slide, please. We provide an integrated suite of reportings to make it very easy to identify what bandwidths, frequencies, and protocols are being covered, and what the quantity of the wireless signal is. You can see our incident reports here that capture the wireless communication. And you can see across the various frequencies and protocols where we have concentration of wireless activity. Next slide, please. Our sensors can be deployed both indoors and outdoors to cover a variety of wireless environments. The system is scalable to cover different size facilities. For example, in an airport environment, you would probably want sensors in the main terminal, as shown in the slide here, as well as on multiple concourses to determine if someone was attempting to compromise your wireless communications. An appropriate number of sensors needs to be deployed to provide total and complete wireless monitoring coverage of the area. And the sensors need to be packaged appropriately if they are to be deployed outside. Another challenge is that the system needs to be able to recognize multiple protocols and frequencies. Next slide, please. Here's an example of multiple areas and facilities where WiFIRE could be deployed, such as where wireless devices are widely used at critical infrastructure facilities, such as dams and water treatment plants, as well as transportation hubs, commercial facilities, and corporate or college campuses. Let me describe how wireless communications systems may be compromised in different facilities by describing several incidents that have occurred in facilities where wireless is used for industrial control and support. First example, at one facility, some equipment suddenly failed to function properly. The incident occurred over several days, and in the absence of a spectrum monitoring capability, all that could be initially determined was that the equipment was malfunctioning intermittently. Eventually, after several days, the RF team was able to identify the frequency and the two people causing the incident. They were both contractors using handheld, unlicensed band radios, which interfered with the operation of the facility. Example number 2. Another large facility used wireless to control their industrial operations. One of the local truck drivers, who was wary of wireless tracking devices, installed a jamming device in the cab of his vehicle to obstruct any tracking devices installed by the owner of the facility. The jamming device was a small module, but was powerful enough to disrupt communications every time he drove past the facility. After several weeks of guesswork and spectrum tracking along the perimeter of the facility grounds, it was determined that the driver was responsible and appropriate action was taken. Example number 3. Another incident involved communications interference problems with a teleoperated crane where the remote unit used unlicensed wireless bands to communicate with the crane. After multiple days of searching, the RF team, using a spectrum analyzer, discovered that the intermittent communication causing the interference was 2 employees that purchased citizen band radios so that they could more easily communicate and perform their jobs better. The last example is that there are multiple attacks that could be performed by a malicious person on Wi-Fi that are documented in the literature, such as a deauthentication attack that targets communications between users and their Wi-Fi access points. These attacks could be carried out intermittently and randomly by small wireless transmitters just plant these devices there and then they leave them. And now your Wi-Fi communications is not functioning effectively. So for each of these cases, a lessons learned analysis shows that an active listening solution with geolocation capabilities could have pinpointed the wireless devices causing problems early on, making the disruptions less costly and faster to correct. The bottom line is that if you want to proactively identify or compromise or interfere in situations and support prompt resolution, then systems like WiFIRE are necessary that automatically monitor the RF spectrum in and around a facility. Next slide, please. I'll just give you a summary of our development history. We have several developers on the team, including the University of Utah. The project started in 2015 with laboratory research funding for 3 years. DHS has been funding the project since then with additional funding from DOE Technology Commercialization Funding, or TCF, Topic 1. We plan on applying for DOE TCF Topic 2 level funding for next year with a commercial partner. We have several publications and patents pending. We have 2 awards, an R&D 100 award and an Idaho Innovation Finalist Award. We have talked to potential customers, such as nuclear power generating companies, through our participation in the DOE Energy I-Core Light program that have expressed interest in WiFIRE to see if we can detect anomalous devices or rogue devices that have been implanted in their facilities or compromised wireless devices. Next slide, please. The technical requirements and the benefits of WiFIRE are: the system is scalable to a customer's environment, as few or as many sensors needed to completely cover a facility or area. There are multiple customer deployment or relationship options ranging from customer hands-on or internal to customer hands-off or managed. The system is scalable to a customer's frequency, protocol, and capability requirements. An annual license fee provides the customer with free periodic software updates during the year to deal with the changing wireless threat landscape. A big advantage is that this system is one tool set rather than many disparate tools that operators need to learn. This reduces operational and training costs. Next slide. Our roadmap to the future is as follows. Current funding is DHS and DOE TCF. We plan on applying for DOE TCF Topic 2 funding with a commercial partner. There will be pilot and field testing this year and next. We will be continuing to improve on our detection, classification, and localization algorithms. We are working at creating WiFIRE hardware and software configurations at different price points and capabilities. This includes computers, sensors, and general capabilities. The development of this tool set is ongoing. Detection and classification algorithms for many wireless signals may be developed in the future depending upon customer requirements, along with general capabilities such as wireless forensics. Next slide. Next are the wireless demo slides. Next slide. Our solution is to be able to deploy multiple sensors to cover both large and small facilities or areas across a range of frequencies and protocols that the customer is interested in. Our tool produces several different reports as output, as you see in the lower right-hand corner of the slide. Next slide. This slide shows the setup in the interior of a building where we have several sensors deployed at the corners of the building, and we can detect wireless devices transmitting within the building. The right side of the slide shows how we set up WiFIRE and configure WiFIRE to do this. Next slide. These are examples of several of the reports that are displayed by WiFIRE that shows the wireless activities that are taking place in the wireless environment that WiFIRE is monitoring. The upper pane shows that we are detecting several different protocols: Zigbee, Bluetooth, WiFIRE, etc. The bottom pane shows the amount of activity in those protocols, as well as a capture of the Wi-Fi activity going through the airwaves. Next slide. This slide depicts Bluetooth traffic that we are detecting in the environment. The amount of traffic is shown in the lower left and right portions of the slide. The right portion shows traffic over time. This is a traffic that we expect to see in the environment that we're monitoring. Next slide. This slide shows how we can create a baseline of our wireless activities and then look at that baseline in terms of the amount or degree of different traffic on different frequencies and protocols. And then we see some visual reports of what that baseline looks like. We can then compare this baseline to other baselines that we could create for traffic representing different times of the day or different days to see the differences in types and amounts of wireless activities. Next slide. We can then configure our system by protocol and frequency to enable notifications of unknown signals detected by WiFIRE. The pop-up alert on the right shows an example of being notified of several unexpected wireless signal transmissions detected by WiFIRE, which could represent rogue devices in a facility. Next slide. And here is a visualization example of some of those unknown wireless signals, as well as a map of where they are detected in a building, geolocation. The unknown signal transmitters are shown in red in the building diagram in the lower left portion of the slide. The sensors are shown in the corners of the building. These unknown transmitters could represent equipment that you simply do not know about that are emitting wireless signals. And the next slide, please. This slide shows the alert that would be displayed on the operator's console, notifying you of the detection of those unknown or unexpected wireless device transmissions. When something comes in that we have not seen before, we're going to get this type of alert. And then the analyst has the opportunity to investigate this problem. Next slide. A camera system integrated into WiFIRE with cameras appropriately placed in the area of interest will then be used to focus on the location of the unknown interfering or transmitting device. So you can see the cameras approximately in the center of this slide for just a portion of the building. Next slide. And then you will see the camera shot of the location of the unknown device that is interfering with authorized communications or transmitting. And that's the end of our slides. Next slide. Any questions?
All right, great. The first question is there a portable mobile WiFIRE capability where a person can walk or drive around a facility to look for an unauthorized or unwanted RF spectrum activity?
Yes, potentially we can just use a laptop with one of our sensors to detect wireless activities. It's just that with one sensor, we wouldn't have the capability to geolocate the signal.
And then I think this has been fully answered, but I want to make sure. It was mentioned that WiFIRE was used to locate interfering wireless signals. Does the device give users the ability to detect the unknown wireless signals, or does it give the user the ability to triangulate the physical location of the device emitting the interfering wireless signal? Example, if a malicious user uses a Pineapple device in an airport, would WiFIRE allow the user to physically identify the exact location of that device?
Yes.
Yep. Okay, and then from our view, I think that's the list of the questions. We're going to move over to the polling, and I just want to let the audience. Actually, there's a new question that came in. Physically identify it to what level?
You mean granularity of location?
Yeah, I think that's what he meant.
Okay. Well, we identify the geolocation of the sensors, and then we use triangulation techniques to identify the location of the transmitting device. So should be like within several meters easily or less.
Okay. Yeah, and I think integrated with the cameras, that's an
Right.
excellent set of tools.
Yep.
Um,